The other day I had to replace a tire on my car. Now, this is no surprise given the state of South African roads, but as I was thinking about the whole process, it got me to thinking about tires. These little things that we go to work with, into the shops with, and that get us home safely, we treat them as consumables. We use them, we wear them out, we complain that we have to pay so much to replace them, and then we ultimately throw them away. But consider this, globally, vehicles travel about 16 trillion kilometers every year. To put that into context, that's about going back and forth to the sun about 50,000 times in 1 year. And the only thing making that possible, the only thing connecting your 2-ton metal box to the ground, well, it's a few patches of rubber about the size of your hand. And today on Applied Mechanics, we're going to be going through what are tires, what are they made of, how do they grip the ground, and how the future of tires might actually be airless. In order to really appreciate the modern tire as it is today, we need to rewind time a little bit. For most of human history, wheels were made of really hard materials, things like iron and wood. So whenever you would go over a bump, you would pretty much break your spine. It wasn't until 1844 when a man named Charles Goodyear figured out that when you boil rubber in a sulfuric acid solution, you get a really stable rubber compound. Now, this process of what's known as vulcanization created a rubber that we could start using for tires. However, this was still a solid rubber piece around a rim, and it wasn't really comfortable. You still had that super bumpy ride. The real game changer came in 1888 when a young man named John Dunlop was preparing his son's tricycle for a race that he was having. He figured out that he would glue a hosepipe onto the outer rim and pressurize this hosepipe to give his son some added performance. And there you have it. That was the invention of the pneumatic tire. A little bit of rubber that's pressurized with air to give a little bit of shock absorption. So now we had the components for the modern tire. We had rubber which was stable, and we could now pressurize the tire. But things weren't really as they are until late in 1946 when the company Michelin patented what is known as the Radial tire. And what they did here was so ingenious. They separated the top tread from the side wall, allowing the side wall and the top tread to complete different functions. And that's the reason today that you can have your car have a super comfy ride and not handle like a shopping trolley. So what are modern tires actually made of? And now, while this might look like a solid piece of rubber, it's actually more of a composite material comprising of things like nylon, steel, and obviously the actual rubber. It's a lot more like reinforced concrete than, say, an elastic band. In general, the main components of a tire itself include the sidewall. Now this gives you a bit of suspension and comfort when you're driving. The actual tread, which underneath here contains all of what are known as body plies or things like reinforcements. Now you have reinforcements running both ways. You have reinforcements running what I would call longitudinally between each side of the rim, and then you have them running radially on the outside of the actual tire tread. And then you have obviously the air chamber inside of the tire. Now we're going to jump over to a lab demonstration so I can show you what's really going on. And here we are in my lab with my lab equipment. This balloon here represents a normal standard tire, although it doesn't have all the reinforcements of a tire. So you can see here I've got a rubber outer lining and then air inside. Now imagine this was a tire on the road. As you can see, when I roll on the road, the tire itself bulges. If I spin it really quickly, it turns into sort of a disc. So this is not really helpful when you want to direct a car where you want to go safely. Now what we can do is, I have here what would be known as a body ply. This is something to keep the balloon more rigid. Now if I put this on here, it's not all the way around, but this acts like those steel reinforcements in the tire itself. Now when I push on it, you can see that the actual side walls of the tire push out, and this is what gives you that suspension. But you'll notice that the part that has the reinforcement on stays pretty flat, and this gives me more contact area on the actual road for grip, and the sidewalls allow to expand and contract, which gives me the suspension and the comfort of the ride. Now, the final component of the tire that I want to talk about is what's known as the bead. If you've ever been curious like me, you would wonder how air doesn't simply just leak out of this tire. And that's because behind this flat part on the rim, you have what's known as the steel bead inside the rubber. If you ever get the chance to see inside the tire, it's a really thick steel cable that runs underneath here so that when you pressurize the actual tire, it seals against the rim itself, with no need for any sealing fluids or glue. And I think that's pretty cool. But the steel bead isn't only to hold the tire to the rim, it actually allows all these reinforcements that run over the side of the tire, it allows them to be anchored onto the bead. And that, my friends, is the composition of the modern tire. Now let's talk a little bit about grip. You might think that the theory is that where the tires point, the car goes, and that's sort of true, but it's not actually that simple. I want you to try this. Take your hand and put it down on a flat surface, like my desk here. Now you'll see there's a bit of weight on it. This would be the weight of your car. Now what I want you to do is, keeping your palm planted and a little bit of force on it, I want you to twist your hand. As you can see, my hand hasn't done anything, but I'm applying quite a lot of force on it. And if we had to actually look at the palm of my hand, you would see a bit of the skin actually twisting, and that is torsional force. This is the same as me having the weight of the car and turning the steering wheel. The wheel itself hasn't turned yet on the surface, but it's that untwisting motion, the rubber basically storing up a lot of energy and wanting to recorrect itself to its normal state. And that's actually how you get the capability of being able to steer. It's not necessarily that you're turning the tire itself, it's the tire itself wanting to untwist and get back to its original state. Now, the technical term for this is what's known as a slip angle. This is the difference between where the actual tire, the rim of the car is pointing, and where the vehicle is actually traveling. That gives you your slip angle. Now, if you have no slip angle, you have no turning force. And the real reason this works is because rubber and gravel really want to latch onto each other. This is known as mechanical keying. There's little microstructures in each material that grip onto each other. So this combination of the stored energy in the rubber wanting to untwist itself and the ability of the two surfaces to grip each other, well, that's what creates the actual grip in your tire and make sure that you don't drive off the side of a mountain when you try and corner. And there you have it. We've gone all the way from a rigid wood or iron wheel up to this pneumatically pressurized engineering marvel. But what's the next step for tires? Where do we go from here? Well, it looks like the next step in tire evolution is the non-pneumatic tire. We've gone all the way from making it so that we could pressurize these tires to actually trying to get rid of the air completely. Now, there are a few advantages to this. The one being obviously that you don't need to replace your tire simply when there's a puncture. There's no ability to puncture it. And one of the pioneers in this is Michelin with their Uptis tire. They actually have a fleet of 50 DHL vehicles running at the moment on these airless tires. So who knows, in a few years, we might be seeing delivery vehicles, maybe even your own vehicle, running with airless tires.